now we're going to talk about naming oxyacids. And oxyacids are still an acid, so it still has to have a hydrogen, but what they include is right in the name, oxy, as in oxygen. So oxyacids contain an oxyanion and a hydrogen. Oxyanions are primarily your polyatomics. The only polyatomics that we really covered that are not oxyanions are your ammonium and your cyanide. Ammonium really doesn't make an acid, and cyanide makes hydrocyanic acid because it's a binary acid. So how we name the oxyacids is you have to determine the oxyanion present because all the names based on the name of the polyatomic. Then you change your endings out. So if it's an ending that ends in ate, so like chlorate, bromate, permanganate, take that ate off and you put an ick there instead. That ends in ite, like nitrite, chlorite. You take that ite off and you add an us, and then of course you then add an acid after it. So HClO3 becomes chloric acid, HClO2 becomes a chlorous acid, but we're going to dive deeper right now into how all of that works. Okay, so naming oxyacids, the basis of them are the name of the polyatomics. So like we went through with binary acids and we did the root, we're going to go through with oxyacids and name the polyatomic. So ClO1- is hypochlorite. ClO2 1- is chlorite. ClO3 1- is chlorate. ClO4 1- is perchlorate. Okay, we're going to move to the next set now, because we're just naming polyatomics. Then we're going to go back through and build the acids and see how these all go to the names. Just like we did with the binary acids, we're going to do the first step first so that we can see how it all works together. So NO1- is hyponitrite. NO2 1- is nitrite. NO3 1- is nitrate. NO4 1- is pernitrate. IO3 1- is iodate. IO4 1- is periodate. SO4 2- is sulfate. SiO4 4- is silicate. Okay, we have a few more on the other page. We have SeO4 2-, which is selenate. We have S2O3 2-, which is thiosulfate. I have BrO3 1-, which is bromate. I have BrO4 1-, which is perbromate. We have PO4 3-, which is phosphate. I have C2H3O2 1-, which is acetate. And I have C6H5O7 3-, which is citrate. Now, these aren't all the polyatomics. They're just a good sampling so you can really get the idea of how you do oxyacids. Okay, so before we write the name of them, let's build the compound. So just like with our binary acids, the charge number tells you how many hydrogens. So ClO has 1 hydrogen, H. and then you just put ClO. So for ClO2, 1 minus, the charge is 1. So you do H, ClO2. For chlorate, it's H, ClO3. For perchlorate, it's H, and then that charge is 1, so it's ClO4. And then you have your nice balanced compounds. The hydrogen always goes out in front, and the hydrogen with a polyatomic shows that it's an oxyacid. So now we have hyponitrite. So it's H, the charge is 1, so it's 1H. And then you write NO. Okay, for nitrite, it's NO2, the charge is 1 minus, so it's H, NO2. For nitrate, the charge is 1 minus, so it's H, NO3. For pernitrate, the charge is NO4 and the charge is 1 minus, so it's H, NO4. There'll never be a like a comp bracket around these or parentheses, because there should never be more than one of your entire compound. So if your compound's NO4, there's one NO4. Okay. So for iodate, the charge is 1. So we do H, IO3. For periodate, it's IO4, but the charge is 1, so it's H, IO4. For sulfate, the charge is 2, so it's H2. That subscript 2 tells you how many H's there are, and then you write SO4. For silicate, it's SiO4, but the charge is 4 minus, so it's H4. And that 4 is a subscript telling how many H's you have, and it's SiO4. Okay, when we look at the next page, we're looking at selenate. The charge is 2, so it's H2, and then you write SeO4. For thiosulfate, the charge is 2, so you write H2, S2O3. For bromate, the charge is 1, so it's H, BrO3. For perbromate, it's BrO4 1 minus. The charge is 1 minus, so it's 1 hydrogen, and you write BrO4. For phosphate, the charge is 3, so you go H3 because you have to say how many hydrogens you need, and then it's PO4. For acetate, yes, it's a big compound, but you still only count the charge. So it's a charge of 1. So it's 1 hydrogen, and you're adding that to C2H3O2. And finally, for citrate, it's C6H5O7 with a charge of 3 minus. So you're adding 3 hydrogens out front, and then you are doing C6H5O7. For your oxyacid. Okay, so the final part of this is actually naming the oxyacids. So we use the name of the polyatomic as a base. So if it's hypochlorite, you write everything up to the ite or the ate. You can write hypo, chlor. Now, you don't write the ite or the ate. Instead of an ite, you write us, O-U-S, and then you write the word acid. So you take off the ite, and then you add an us, and then you add the word acid. So hypochlorite becomes, when you add a hydrogen, becomes hypochlorous acid. So chlorite, you write everything up to the ite, so it's C-H-L-O-R, and then you write us, O-U-S, and then you write the word acid. So chlorous acid is chlorite with a hydrogen. So for chlorate or HClO3, as an oxygen, you write everything up to the ate, so it's chlor, C-H-L-O-R, and then you take off the ate and you add an ic, so it's chloric acid. So you're just swapping endings. So perchlorate, you write everything up to the ate. So it's per chlor, and instead of ate, you write ic. So perchloric, and then you write the word acid. So hyponitrite, you write everything up to the ITE. So H-Y-P-O-N-I-T-R, and instead of ite, you wrote us, O-U-S, and then you write the word acid. For nitrite, you write everything up to the ITE, so it's N-I-T-R. Instead of I-T-E, you write O-U-S, so nitrous acid. For nitrate, you write everything up to the A-T-E, so N-I-T-R, but instead of A-T-E, you take that 8 off, you add an I-C ending, so it becomes nitric acid. And that's what happens when you add hydrogen to nitrate, you get nitric acid. So for pernitrate, you write everything up to the ATE, so it's P-E-R, N-I-T-R, but instead of ATE, you end it with I-C, and then you write the word acid. So for iodate, you write everything up to ATE, so it becomes IOD. And then instead of ATE, you're adding IC, so it becomes iodic acid. So for periodate, you write everything up to that ATE. So it's P-E-R-I-O-D. Instead of that ATE, you're writing IC, so periodic acid. Now, for sulfate, you write everything up to that ATE, so you write SULF. And you have to remember for sulfur, it doesn't want sulf, it wants sulfur. So you have to fix your root for sulfate. You write everything up. So you've got to fix the root. Instead of 8, you add ic, so sulfuric, and then you write the word acid. So that's one of those funny ones where you have to make a correction. It's sulfate and phosphate. So sulfate, you write the root becomes sulfur. It's a funny one. And then for silicate, again, you're writing everything after that ATE. So you write S-I-L-I-C, so it's silic. Instead of ATE, you write IC, and then you write the word acid. Okay, so for H2SeO4, for selenate, you write everything up to the 8, so it's S-E-L-E-N, and instead of 8, you add I, and then acid, so it becomes selenic acid. So for thiosulfate, you write everything after the ATE, so you write thio, and then sulf, and then you have to remember that the root sulf doesn't stay sulf with acids. You have to add that UR, so it becomes thiosulfur. That 8 becomes IC because you're switching your endings, and then acid. So thiosulfate with hydrogen is thiosulfuric acid. So for bromate, when you add hydrogen, you write everything up 8, so that's BROM, and then that 8 becomes ic, you switch it out, so then you write the word acid. It becomes bromic acid. So for perbromate, this is when let's add hydrogen to it, so you have HBrO4, you write everything after that 8, so it's PERBROM. Instead of 8, you write ic, so it becomes perbrom, and then you write ic, and then don't forget to write the word acid, perbromic acid. Phosphate, when you add hydrogen to it, you write everything after that 8, so it's PHOSPH, and then you got to remember with phosphorus, or P and phos, the root's no longer phos, it's phosphor, so you have to add that OR, and then 8, you got to add ic, so it becomes phosphoric acid. So your P's and S's change. You have to make sure you're taking that into account when you're writing your acids. Acetate, you write everything up to the ATE, so it's ACET, and then you take that ATE and put IC, so it becomes acetic acid. And finally for citrate, you write everything up to that ATE, so it becomes CITR. Then you take that ATE, put IC in, so it becomes citric acid. And this is how you go from a polyatomic to a balanced acid to an acid name using your polyatomic roots and for naming oxyacids. Thank you.